All right, so other trigonometric facts. All right, this is what we call a cast diagram. When I was in college, UTech was called CAST, which is the College of Art, which was the College of Art, Science, and Technology. All right, so that's when I was in college. But separate and apart from that, this is what you call a cast diagram. Now, what the cast diagram does is that it helps you to remember um, in which quadrant is sine, cosine, or tangent positive. All right, so we have cast. C for cast, it refers to the fourth quadrant. A, the first quadrant. S, the second quadrant, and T, the third quadrant. So first of all, quadrants, the first quadrant is between 0 and 90 degrees. The second quadrant is between 90 degrees and 180. The third quadrant between 180 and 270. The fourth quadrant between 270 and 360. So quadrants are labeled with Roman numeral. Now, what CAS is saying is that C from CAS is telling me that in the fourth quadrant, cosine is positive. So there's sine, cosine, and tangent. Cosine is positive in the fourth quadrant, and sine and tangent are negative. A refers to the first quadrant, and the A there is telling me that in the first quadrant, all are positive. Sine is positive, cosine is positive, tangent is positive. So the sine, cosine, and tangent of every angle between 0 and 90 degrees is positive. In the third quadrant, CAS. In the third quadrant, sine is positive, cosine and tangent is negative. In the fourth quadrant, tan is positive, sine and cosine are negative. All right, so the cast diagram is something that you must have in mind. It is extremely relevant, extremely important. All right, here are some other facts. Complementary angles. Now, complementary angles are two angles that add up to 90 degrees. Complementary angles are two angles that add up to 90 degrees. Now, if A plus B is equal to 90 degrees, the sine of A is equal to the cosine of B. And that is why, for example, the sine of 30 degrees is a half, and the cosine of 60 degrees is also a half. So 30 degrees and 60 degrees are complementary angles because they add up to 90 degrees. And the cosine of 30 degrees, which is √3/2, is equal to the sine. Sorry, not 30 degrees, 60 degrees. The cosine of 30 degrees is equal to the sine of 60 degrees, which is also √3/2. So if A plus B is equal to 90 degrees, the sine of A is equal to the cosine of B, the cosine of A is equal to the sine of B, and the tangent of A is equal to the 1 over the tangent of B. This is important, but something I think you could get from your cast diagram. Supplementary angles. Supplementary angles are two angles that add up to 180 degrees. So if A plus B is equal to 180 degrees, the sine of A is equal to the sine of B. So the sine of 30 degrees is equal to the sine of 150 degrees, which is equal to a half. Because 30 plus 150 degrees gives you 180 degrees. The sine of, if A plus B is equal to 180, the sine of A is equal to the sine of B, and the cosine of A is equal to minus the cosine of B. The tangent of A is equal to minus the tangent of B. This will be very easy for you to produce or reproduce once we understand the issue of cos and reference angle fully. All right, let me just erase some stuff. We could erase this if we want to. All right, let's move down a little bit. So let's talk about the reference angle. Very, very important. Now, this says the reference angle of an angle. So reference angle don't just exist on its own. It is the reference angle of an angle. Is the positive acute angle, the positive acute angle, the positive acute angle, the terminating side of the angle makes with the x-axis. All right, the positive acute angle, so the word angle should be here, sorry. The positive acute angle, so angle should be here. The terminating side of an angle makes with the x-axis. So this is the x-axis that they're talking about. This is the x-axis that they're talking about. So now in the diagrams here, the red angle is the reference angle. The red angle is the reference angle, and theta is the angle. So in each case, in each diagram, alpha is the reference angle and theta is angle. So alpha is the reference angle of theta. All right, in the first quadrant, you'll notice that the reference angle of theta is alpha, and that alpha and theta are equal. In the first quadrant, theta is the reference angle. Sorry, theta is the angle. Alpha is the reference angle. You'll notice in the first quadrant that the reference angle is equal to the angle. The reference angle of the angle theta, alpha, is equal to theta. Remember, the reference angle is the positive acute angle the terminating side of the angle makes with the x-axis. All right. Second quadrant, the angle is theta II. Theta II is the angle. So this is the first part of the angle. Let me just change to maybe green. This is the first side of the angle. We have 0, that's the first side. This is the terminating side of the angle. So this is the angle. The angle is theta. The terminating side of the angle is here. Now, the angle that the terminating side makes with the x-axis, that red angle there is called the reference angle. All right. So you'll notice that the reference angle alpha in the second quadrant is equal to 180 degrees minus theta. So for example, if theta is 150 degrees, the reference angle would be 180 minus 150, which would be 30 degrees. So the reference angle for 150 degrees, which is in the second quadrant, is 30 degrees. In the third quadrant, So in the third quadrant, this is very important knowledge. Try and get it to sink in. In the third quadrant, this is the angle here. So in the third quadrant, that's the angle. You can see it is a reflex angle, more than 180 degrees, but less than 360 degrees. It's a reflex angle. It is in the third quadrant. Guys, hold a second, please. All right, so where was I? So you'll notice that this is the terminating side of the angle in the third quadrant, and the angle formed by the terminating side of the angle and the x-axis, that angle is called the reference angle. So in the third quadrant, the reference angle is theta minus 180 degrees. So for example, 270 degrees is an angle in the third quadrant. The reference angle for 210 degrees is 210 degrees minus 180, which is 30 degrees. Finally, the fourth quadrant. So here is an angle in the fourth quadrant. This is the angle. It starts here. So that's the angle, more than 270 degrees, but less than 360 degrees. This is the terminating side of the angle. Now, the angle formed between the terminating side of the angle and the x-axis, that angle, that red angle alpha, is the reference angle. So in the fourth quadrant, the reference angle is 360 degrees minus theta 4. So for example, if let us say 200 and what? Let's say 300 degrees. The reference angle for 300 degrees would be 360 degrees minus 360 degrees, which would be 60 degrees. Now, what's the relevance of the reference angle? Here it is. Very important. What's the relevance? The sine, cosine, and tangent of an angle has the same numeric value of the sine, cosine, and tangent of its reference angle, but the sign might be different. Extremely important. The sine, cosine, and tangent of an angle has the same numeric value as the sine of the sine, cosine, and tangent of its reference angle, but the sign might be different. So for example, the reference angle for 150 degrees is 30 degrees. It's 180 minus 150 degrees is 30 degrees. What this is saying is that the sine of 150 degrees is the same as the sine of 30 degrees. The cosine of 150 degrees is minus the cosine of 30 degrees. And the tangent of 150 degrees is minus the tangent of 30 degrees. What else? Continuing an example. For example, 240 degrees. 240 degrees is third quadrant. The reference angle would be 240 degrees minus 180 degrees is 60 degrees. What is the relevance? The sine of 240 degrees is minus the sine of 60 degrees. 60 degrees is its reference angle. The cosine of 240 degrees is the same as the cosine minus the cosine of what? 60 degrees. And the tangent of 240 degrees is equal to the tangent of 60 degrees. And that is because in both the first quadrant and the third quadrant, tangent is positive.